Welcome students. Today we are going to look at another topic in Form 2 mathematics, that is trigonometric ratios. So in trigonometric ratios, this we are going to look at introduction, where they deal with right-angled triangle. They deal with right-angled triangles. A right-angled triangle is an angle that has a 90 degrees. It has an angle which is 90 degrees. So when you look at this example of triangle, which is a right angle, this is the symbol of a right angled triangle. So this is a right angled triangle. When we have angle theta, which is here, so when the angle theta is here, this is going to be the opposite side, and when the angle theta is here, the downward part is going to be the adjacent side. Good. So and the longer side is going to be the hypotenuse side. Good. When we have this second example of our right angled triangle, so when the angle theta is here, you can see on our example A, it was here down. So when the angle theta is now here up, so this side is going to be the opposite side, and this side is going to be the adjacent side. Well, the longer side is going to be the hypotenuse side. Now, once you know now the right angled triangles, now we are going to look at the trigonometric ratio. So we are going to use the common acronym, that is SOHCAHTOA. So S in the acronym SOHCAHTOA, S stands for the sign of the angle, then O stands for the opposite side, then H stands for the hypotenuse side, then C stands for another trigonometric ratio known as cosine of an angle, then A stands for the adjacent side, H stands for the hypotenuse side, then T is another trigonometric ratio known as tangent. So T stands for tangent of an angle, then O stands for the opposite side, then A stands for the adjacent side. So when we begin with the trigonometric ratio, sine of an acute angle. So sine of an acute angle is an angle that is less than 90 degrees. So when we have sine of theta, now example our theta is here, so we are going to take the opposite side, which is here, then we divide it by the hypotenuse side, which is here, which is the longer side, and we are going to get the sine of theta. And when we are looking at the cosine of an acute angle, cos theta, we were here, so cos theta is adjacent over hypotenuse. So cos of theta is equals to the adjacent side over the hypotenuse. And when we look at the tangent of an acute angle, we are going to have tan theta is equals to, when we use our acronym, opposite over adjacent. So our tan theta is equals to opposite over adjacent side. So the next time we are going to look at the examples of trigonometric ratio, but this is the three trigonometric ratios that we are going to look at. We are going to look at the sine of an acute angle, which is equals to opposite side over hypotenuse. We are also going to look at the cosine of acute angle, which is the adjacent side over the hypotenuse. And lastly, we are going to look at the tangent of acute angle, which is opposite side over adjacent side. So we are going to look at the following examples. So in example 1, we have been told is in the figure above, adjacent length is 4 centimeters. As we said earlier, when the theta is here, the adjacent side is here down. So the adjacent length is 4 centimeter, and the angle theta is 36 degrees. So angle theta is 36 degrees. So we are going to calculate the opposite length. So the opposite length, when the theta is here, it is here, opposite length is there. So we are going to calculate the opposite length in our solution. So when we are dealing with the adjacent side and the opposite side, well, we use the tan. Remember our acronym that we learned, which is, remember our acronym, which is SO, CA, TO. So to get the, when you are dealing with the opposite length and the adjacent length, opposite length, adjacent length, we are going to use tan of theta. So we cannot use sine, so sine deals with the opposite and the hypotenuse. Here we have not been given the hypotenuse. We want just to go direct to solve to get the opposite length. So we are going to use the tan of theta, and also we cannot use the cos, it will be a long way. So because it's the adjacent and the hypotenuse, yet we don't have the hypotenuse. So we are going to use what we have been given so that we get the opposite length much quicker. So we are going to use the tan of theta. So and our theta is 36 degrees. So we are going to look tan of theta, which is 36 degrees, is equals to opposite length all over the adjacent length, which in our triangle, the adjacent length is 4 centimeter. Good. So in order to get the opposite length, we are going to multiply all sides by 4 centimeter. So we are going to multiply here by 4 centimeter and here by 4 centimeter. So this 4 centimeter cancels out here. So we are left with the opposite length to be 4 centimeter times the tan of 36 degrees, which when you calculate in your calculator, the tan of 36 degrees gives you 0.7265. So it becomes 4 times the tan of that 6. You can use the tables or the calculator. So it is going to give you the 0.7265. 0.7265. So when you multiply in your calculator, it's going to give you 2.9060 centimeter. So that is how we get the opposite length given the adjacent side and the angle theta, which is 36 degrees. The adjacent side was 4 centimeters. So that is how we get the opposite length. So when we are going to look at the following example, example 2, we are going to have the question reads, in the above opposite side is 5 centimeters. So the opposite side is 5 centimeter. So this is 5. So we said when the angle is here, the opposite side is opposite, which is 5 centimeter, and the adjacent side is going, we have been told, is 12 centimeter. So calculate the angle sine x degrees and cosine x degrees. So let's look it in our solution. So using the acronym So cut off because it helps us to remember how to get the trigonometric ratios, so we can write them for us to remember the formula. So ka to. So we are going to have the sign. We have been told first we get the sign of x degrees, which is given by opposite side over the hypotenuse side. So opposite side, opposite over the hypotenuse. So the opposite side we have been given as 5 centimeter, and the adjacent side we have been given as 12 centimeter. So when you divide, so the answer you can leave it also as a fraction. So our answer can be 5 over 12, or also you can leave your answer in decimal form. So when we look at the cosine x, cosine of x, which is abbreviated as cos x. So cos x, using our acronym, is adjacent over hypotenuse side. So it's equals to adjacent over hypotenuse. So what is the adjacent side? The adjacent side of x is 12 centimeter. What about the hypotenuse? So we don't have the hypotenuse, so we are going to look for the hypotenuse, where we use what we learned, the Pythagoras theorem, to get the hypotenuse. So when you look to get the hypotenuse, so we said hypotenuse squared is equals to the square of the two shorter sides, so is equals to 5 squared plus 12 squared. So 5 squared gives you 25, plus 12 squared gives you 144. So the hypotenuse squared gives you 25 plus 144, which is 169. Then to get the hypotenuse, you get the square root of 169, which gives you 13. So our hypotenuse is 13 centimeter. So we are going to divide with our hypotenuse, 13 centimeter. So centimeter and centimeter cancels out, so the final answer gives you 12 over 13. So those are the few examples in the trigonometric ratios. So these are among the few examples that we have looked at. So we have looked at to get the one of the sides, the opposite length. So here we have looked at the sine x and the cos x of this triangle. So remember also to subscribe and for more videos, so that we can look at more examples in our next videos. Thank you so much. God bless you.